You up for one more?
Yeah, absolutely.
All right. So the last one features George Hotz, which some people might
Okay.
remember from hacking the original PlayStation 3 and the iPhone.
I remember him from telling Elon he would solve all of Twitter's problems in a week.
He tried. The one thing most people might not know is he's also been on and off involved in some Ethereum stuff. One of the interesting attributes of Ethereum is this collectively owned computer, essentially. We have these guarantees where all the code executed on it will be 100% right because every node verifies it.
For some values of right.
One of the kind of the constraints in order to maintain these decentralization properties and for everyone to be able to run a node at home on their laptop, there's a fairly small limit on how much throughput it can handle. People often make fun of it for having something like 10 transactions per second. But turns out we can solve it by this innovation called rollups, and essentially we can run the transaction somewhere else, and we basically commit to a batch of transactions on Ethereum, and we can prove that they executed accurately. So back when these rollups were first kind of designed / discovered, the theory of it was fairly well established, but implementation was still kind of a long road ahead. The people working on these rollups, they're hanging out in like a San Francisco cafe, and they're just like bashing their heads, like, how are we going to build this? They turn and George Hotz is there next to them. They know he's really smart, so they just like start like brainstorming with him, and he gets nerd sniped. And they basically convince him to build a proof of concept of a rollup in exchange for a very generous amount of money. But the term that they came up with is that they're gonna do an initial bug bounty and a like $50,000 bug bounty, but the money's going to come out of his compensation if there's bugs. Long story short, we got $50,000.
Howdy, folks. We are back once again on the War Stories podcast on Critical Point. Today I am here with a friend of a friend who I met through Twitter, Andrei Petrov, chat about that time he broke production. That's what we do here, or several specific varieties of production. I think we have a few stories here maybe to chat through. So very little preamble today. As always, we are available at warstories.criticalpoint.tv on all your podcast apps if you are watching this on video, and on YouTube at criticalpoint.tv if you would like the video. But I'm excited to get stuck in and don't have too much more to say than that, so we will roll the titles and get started. And we're back. Once again, this is the War Stories podcast on Critical Point. I'm Kevin Riggle, and I'm here with Andrei Petrov. Andrei, can you tell us a little bit about yourself and how you found yourself in a place where you might break production?
Hi. I am an independent open source developer. I've been largely building open source things since 2007 or so. One of my most known things is urlib3. It's an HTTP library in Python that's used by a lot of people.
That lies under like the requests library, which is
right.
used by everybody, which is now baked into the Python standard library, if I recall.
Not super much,
Okay.
But like pip uses urlib3 as well. So basically, anytime you've done any kind of Python stuff, you've probably run some of my code.
I think, every time I see a Python exception, half the time it's got urlib3 in there somewhere. So, yes.
Yeah.
Yes.
Although there's a bunch of other people working on it and like maintaining it these days. So I kind of more do meta maintaining.
Okay. Community management kind of things, or
something like that. Yeah.
Okay. Yeah. What got you into doing that?
My first job, so basically we were uploading a lot of images to S3 at the time. We were actually one of the largest S3 customers. This is 2008, maybe. And turned out the state of HTTP libraries at the time was not great. So every request was like a separate socket, separate everything.
Yeah,
and
it was dire. I remember this. It was bad.
Yeah. I estimated how long it would take us to upload all the images we had, and it was like 3 months or something. And they're like, I could write an HTTP library in less than 3 months. So while that's going, I basically wrote what later became urlib3, largely support for multi-threading, support for using sockets, a whole bunch of stuff like that. And then we got that down to I think like 3 or 4 days. And they very generously let me open source it under my own name and kind of one thing led to another from there.
And so, but that comes sort of after the
No.
story that we're talking about. Like,
Yeah.
yes, because this story, if I recall from our conversation, starts in high school.
Yeah. So originally, I started coding in my early teens, and my high school had this really. I went to this like big public high school, and they had this half-assed computer programming class that was organized by our gym teacher who has never written any kind of code.
Okay. Oh goodness.
And
Okay, sure. Why not? Great. Good for them.
yes, but yeah, they kind of handed us a book, which I think was we did some Turing, and I think at some point C. I chose to learn C, and that was going on. And I was also at the time was working my personal website, which I ended up using PHP for, and I was kind of doing some work for our high school. Our high school needed we didn't have any kind of software, and their rooms were constantly their like booking system was kind of this just like a piece of paper on the wall, and people were constantly running into each other. So I built them this kind of booking suite, and that they really liked.
So I'm getting this sense that you're like maybe about my age, and you're doing this maybe in the early aughts.
Yeah. This is like started around 99, and kind of the incident happened around 2000.
Okay.
And very important context. This is the age where people were using modems. So this is like 36K modems, maybe 33.6K modems, maybe 56K modems are just have just been released.
Okay, yeah. So we're at this moment where the internet is taking off in a big way. A lot of people are coming onto the internet for the first time. Like I'd been on the internet for, since the mid 90s at that point, with the dial-up account. And so, but yeah, a lot of people were coming on for the first time.
Yeah, I would say we're probably a couple of years behind you there. Like at least back then. So this is like almost everyone is on like a 33.6K modem. Just like a few people got a 56K just now. So basically, I'm kind of unofficially just kind of building software for my high school. I think at one point they like paid me $200 or something. Kind of just like it gave me some cash.
Kind
like,
of an honorarium.
Thanks.
Yeah, you're probably like 15, 16. They maybe can't even officially employ you yet. Like,
yeah. And then one day they approached me. It's like, oh, we want to send a newsletter to all of our alumni. They have this basically the CSV of around 1,000 email addresses, and they want to start sending these monthly newsletters. And they don't have like newsletter software doesn't exist back then. So they're like, how do we do that? Can you like write us a thing to do it? So I go to my PHP and I start. That's mainly the reason I wrote it in PHP is because I knew how to run it and deploy it. And it had kind of the like SendMail API built into it somehow. So I'm writing my PHP. I got my loop. I go over every email address. I send the email. I run it locally. It's slow, but it works great because it's a modem. That was okay. And then I bring it to them. Oh, wait, we want to also attach a PDF to it. And it's like a 1.5 meg PDF.
Okay, yes.
It's really big. And
yes,
I don't know, I might have mentioned something at the time. It's like, oh, that's really huge. It's like, yeah, whatever, it doesn't matter. So I tried running it locally, and I'm on like a 36K modem, and it's really slow because uploading 1.5 meg 1,000 times, it's going to take me a week. So I had this brilliant idea. Well, instead of sending a bunch of 2 emails separately, I'm just going to BCC everyone.
Right.
With one email. So that way I only have to upload it once and let them
the mail server figure it out. Yes.
Yeah.
Yes. Exactly. Yes.
So I have this very vivid memory. I have my loop, and then aside, I'm going to keep that loop for now. I'm going to write another loop underneath it to kind of accumulate the BCC string. So I'm looping over all the email addresses. I'm building up a big string to put in the BCC. And I don't know if you can guess where this is going. I have some
guesses as to where this is going. Yes.
Yeah, so I wrote this. I tested it with like one email, worked great. I get the gym teacher had this server that they rented. He gave me the login and password and their mail server and everything. I log in. It's really fast. I think it was like running on like a T3 or something.
Okay.
Like I've never touched a server this fast. So I was really excited.
Power, yes.
Yeah. So I upload my PHP in there. I uploaded my inputs. I go to the PHP endpoint, which is how I would run PHP back then. I just open it in my browser and then just kind of like let it spin. And it's like taking a while. It's taking a while. I'm like, oh, it's taking a while. I would think it would be really fast. It's like a T3, so it should be really fast. And it's sitting there, and then I'm kind of like, as it's going, I'm kind of replaying all my lines of code in my head that it should be running.
Right.
And then I had this realization: I never took out the outside loop.
Right. Yes.
So basically, what happened is I sent a 1.5 meg PDF 1,000 times on a 33K modem.
Oh no!
In their inbox, so they got over a gig of email blocking their inbox. 1,000 people, which is basically like everyone ever went to the school.
And this is in the era where people's inboxes were generally limited to like 10 megs.
Well, there's that, but also there wasn't any kind of server-side mitigations. Like the idea of like what accidentally did is this denial of service attack, basically. And maybe I was the one that encouraged them to build some mitigations for that. Maybe not, but there weren't any at the time. So
you were certainly part of the wave of like adversarial behavior, even though here the adversary was as much Murphy as anybody, to encourage the formation of those controls.
Yeah, so basically for the next 2 weeks, our school just getting nonstop calls from everyone that ever went to that school. It's like, I can't get my email. I can't get my email. People are like leaving their computers on for days at a time, trying to download everything. I got brought down to the principal's office, had to give a like formal apology, whatever that means. Yeah.
Were there, besides sort of like calling you on the carpet and making you sort of promise to never do it again, were there any other like repercussions, or
no?
how'd they handle it?
The way I remember it is they wanted to keep using it after I fixed it. So I built them a little UI, and I think they kept using it for some number of years afterwards. I think they paid me around $80 for that one.
Okay, great.
Okay, so yes. Maybe they got what they paid for. I don't know.
Yeah, I mean, we always do. Yes, we have the best humans available.
I did the math on this. It would have taken them 3.5 nonstop days to download everything in their inbox in order to get access to their later emails.
Okay. Or could they call up the ISP and be like, "Hey, please delete everything in my inbox"? I don't know.
I mean, I'm sure some have tried. I can only imagine what the level of competence was back then.
Yeah. Well, you have to get through. I mean, I don't know. We were on a little rural phone company, so like the odds of actually getting through to somebody with root privileges on the email server were actually fairly high.
Fair, yeah. We're like in a little city with kind of a national telecom, most people using. Yeah, so I don't know. Anything's possible, but I think most people just left their devices on for the half a week and let it plow through.
Oh my god. Okay. Well, and this is like we had a gig's worth of hard drive space, but we had a gig's worth of hard drive space. So like, that's quite a substantial amount of stuff to download and then delete. Goodness. And this was also in an era where, I don't know about you, but on my dial-up line, well, okay, so first of all, we were lucky to have the dial-up line before we got DSL on a separate line, because otherwise it would just tie up the main phone line, and that was the main point of contact for everything. My dad's a pastor, so that was how his congregation
livelihood.
That was how his livelihood. Like, for the longest time when I was young, I could only be on the internet for 30 minutes because that was the longest my parents were willing to have the phone line tied up for dad's work stuff. But once we got the second line, it was still the case that it would kick you off after 12 hours, which I remember because I was trying to download my first ever set of Linux ISOs. Like Red Hat 7 or something. And was like, oh, I it's free. We can technically speaking download it, but it was going to take several days. And after 12 hours, we got kicked off. Like,
and also back then, resuming was very unreliable too.
Extremely unreliable. Yeah.
I remember downloading the Diablo 1 demo. It was like 54 megabytes.
Okay, yeah.
Which was like 16 hours of downloading or something like that.
Yeah.
And my computer would blue screen right before it finished.
No.
But that was kind of the impetus to get me to, like, I rage quit Windows so hard when that happened.
Yeah.
that it actually like I got to reinstalling operating systems and like formatting things, and like I
Right.
got to the next level, and then eventually using Linux and all that. So
Yeah,
I
same.
guess it was a
Yeah.
good thing in the end.
Yeah, same. My first Linux came out of a CD at the back of one of those books. I think it was Caldera Open Linux, and it was like learn Linux in 30 days or something, you know. Uh, yeah, that was wild. So cool. Yeah. Okay. Very much that early scrappy era of the internet when everybody is still figuring it out. Like nobody's quite sure yet if it's going to be a big deal or not.
Yeah, I mean, in retrospect, like I was kind of writing down notes earlier and kind of reflecting that experience. And on the one hand, you can say it was irresponsible of the gym teacher to enlist me this way, but on the other hand, that was really useful, very hands-on experience
Oh,
that
absolutely.
I feel like has had very substantial impact on me moving forward. So I really wish more students would have that kind of opportunity to kind of make these kinds of mistakes.
Yeah, for sure. Yeah. I don't know, I was very desperate in that era for any kind of real thing to do with
Yeah,
my computer programming experience, my, computer interest. And I really
yeah.
struggled to find people who were willing to let me, make those mistakes.
Yeah. I remember a lot of our kind of computer class assignments were just glorified interview questions,
Yeah.
basically. Like,
Yeah.
which,
All like little programming puzzles. Like,
yeah,
yeah, we did some programming competition stuff, which were all structured as like, take this as input, do a little algorithm on it, produce this output. And it was fine.
but you don't learn to actually comment out your extra for loop before writing your other loop
Right.
until
Yeah. Yeah.
until you actually do something in production.
Yeah, exactly. Yeah. Well, and if you hadn't done that, somebody else would have and did probably. It
Yeah,
probably took several, rounds of that before the administrators implemented whatever, send mail, limits were available and whatever, mail server they were running, whatever postfix limits were available on the receiving end, and like started to think harder about that. Because yeah, spam was only just kicking off and their spam filtering was not yet a substantial thing. I was starting to play around with like Spam Assassin or whatever the built stuff that was built into like the Linux email client was in that era, or just a little bit past that era. So yeah. So what happened? Where did you go after that? After drawing the attention of the entire alumni community of your high school, and
I
not in a
mean,
particularly positive way.
yeah. Ultimately, it was kind of a non-event. I don't think anyone kind of remembers it except me.
Yeah.
Yeah, and then I went off to university, studied computer science, did the EuroLib 3 stuff, moved to Silicon Valley to do my startup pilgrimage that I'm obligated to do.
As one does. Yes. Yes.
Yeah.
Excellent.
Yeah. So around then, I was working on these social analytics applications. So the next story, uh, this one's not really my fault, but also kind of a war story. So I built this Twitter analytics tool called Tweepsect, and basically what it did is I loaded your graph and it did a set intersection. So everyone that you're like following, everyone's following you. You do the intersection and give you your mutual followers, who's following you only and who you're following only, and then I refer to them as stalkers and stalking,
Okay. Yeah.
which is kind of
Right.
uh,
Like you
got
do.
people excited.
Yeah.
Uh,
Okay.
and one cool thing about the way that app was built is it was pure client-side JavaScript.
Okay.
So there was a small server-side uh, shim to do the OAuth handoff, but after that, it was entirely run in browser, which is really cool because we basically have infinite scaling without any kind of cost. It was like literally just like a static website otherwise. Um, and so this is like back when Twitter had an open API that everyone could use.
Right. Yes. Yes.
Anyway, so, and then the other thing that's kind of relevant is I also have built another social analytics. I was building like this like social analytics startup called Social Grapple, and I was going through these acquisition talks. And one of the talks was actually with Twitter. So I had just met their director of platform just a few weeks earlier. So I built this sweepstakes thing kind of the year before, and then a year later this is happening. So I met their director of platform. We talked about acquisition stuff. It kind of didn't super work out. And if fast forward a few weeks later, I used Google Analytics to track who's using my stuff, so I could see kind of like a real time thing of people kind of searching, and I would get maybe a few dozen people a day, maybe like a few thousand or like 1,000 people a month using this thing. And then one day I open up Google Analytics and I see all of a sudden there's like thousands of people there at the same time.
Okay.
I'm like, what's happening?
What just happened?
And I assume it's a bug of my analytics. So I go in the app, check that, everything looks fine. I search on Twitter, people mentioning it, and it's being mentioned. And then every so often I see a mention with my app's name, but with a different link. It had a different link to it. And I opened it incognito and I checked, and it's like exactly my app. I even had my like analytics code in it and everything, but it's on a different URL.
Interesting. Okay.
Yeah. And when you click login, it goes to like this like Twitter login form, but it's not on twitter.com. It's on the itwitterer.com or something like that.
Okay.
They kind of bought another domain that looks similar.
Right. Classic.
Yeah.
Yes.
So what happened was they stole my app and they built this like phishing website where they would harvest people's logins and then they would redirect back to my app. So I would still get all the traffic, which I appreciate.
Okay, great. Yes, glad that worked out. Yeah, it doesn't always.
Yeah. But then once they stole the logins, they would go through everyone who's following you and they would DM everyone that link. So it would spread virally. Everyone would get a DM. It's like, oh, check this out. I looked up who's like stalking me. You should try it. Or something along those lines.
Somebody was running a viral marketing campaign for you.
Exactly. But they were also stealing everyone's login password. It's kind of weird because I had this basically live dashboard of every account that's being stolen.
Oh, sure.
In real time. So just like the numbers just like going up like crazy. So I mentioned the like Twitter support team and stuff, and like, hey, can you help? Can you do something about this? No one answered. But luckily, I just met the director there, and I emailed them. And then even though it was like 11 p.m. at night, he like responded a few minutes later, and allegedly they were on it.
Okay. Yeah.
But the interesting thing is that it kept going for kind of about a month. After that, look at my analytics and like drop for a few hours.
Okay,
which I'm assuming they're kind of playing some weird kind of some cat and mouse game.
Maybe,
with their like with their authentication flow to kind of try to block them.
Okay,
and then it would go back up like a day later because they would just change their method.
Okay, interesting.
And the other funny thing about that one was that they were live. They had a live proxy of my website, so I could make changes on mine. It would be reflected on theirs. So I put up a big fat warning, and it showed up on theirs as well. But unfortunately, that also prompted them to eventually stop doing that method, and they just kind of they just stole it wholesale.
Okay.
And yeah, it's kind of interesting. I mean, based on my analytics, some like hundreds of thousands of accounts were harvested, and even made it into mainstream news at some point. If you search for stock track, it was like mentions on it because they like, kept it doing stuff with it. They kept trying to like harvest more and more, just in more ways. And I think up to like 2015, there was some mention of it to say like, this is a scam, don't log in with this app and stuff like that. So yeah, that was really wild. But yeah, ever since after that, I went from having around 1,000 visitors a month to having about 100,000 visitors a month, and it kind of like stayed that way for at least a year or two, and then I put some ads on there. I made a few $100.
Yeah, for sure. Yeah, I wonder, did you ever figure out who was behind it, or have any guesses as to what the attribution was?
I mean, given that they kept going with it and kept kind of it just kept like building other scams, it feels like some kind of team somewhere that's been doing this for a while, and they're going to keep doing it. So no, I don't know who's behind it, but it feels like one of those things that just kind of, there's an adversarial group out there, and then there always will be, and they just happen to launch with my app,
with your app.
And,
that's the sort of carrot. Yeah, that's interesting.
Seed. Yeah,
exactly. You hear about all these influence operations, and this is a little bit of a window into how they work. It's very convenient of them if there is already something in the environment which they can appear to be like, already something legitimate, which they can copy like this and leverage, because that means people are coming into this from a place of like, oh yes, this looks legitimate, this looks like it's done by somebody, rather than
even if it doesn't look super legit, it's just like it's an interesting use case that you can kind of use as a distraction.
Yeah,
I think.
for sure. Was there
Uh,
ever any sense of what they were doing with the accounts? Like, were they using them to send other kinds of spam, or?
that's a good question. Yeah, it's a good question. This was back before the day of password managers, so I'm
Okay.
assuming they were also reusing the logins on other websites.
Oh, for sure.
That would be
Yeah.
my guess.
Okay.
The other thing that's interesting is like there's basically no mention of this. Like probably 500,000 accounts got harvested, and it wasn't really in the news or anything. And like Twitter didn't make an announcement. I mean, it's not technically their sole responsibility, but also like it's a
Well,
substantial number, especially for
yeah.
this was 2011.
Yeah.
So
Okay. Yeah. Yeah. Um,
Twitter
okay.
wasn't
Yeah.
that huge.
We hadn't yet quite figured out how big a problem account takeovers were going to become, and quite exactly what
Yeah.
that was going to look like at that era. But yeah,
But I think it's still happening on other services in some
for sure.
way, shape, or form, and we just kind of never hear about it. So it's kind of interesting to be in the eye of the storm, almost just like having a real time analytics dashboard. Like what are the odds
right?
of getting that right?
Yeah. That's actually a very interesting data set. I don't know if you still have access to that, but it seems like something that could be interesting for one of these account security researchers to take a look at and maybe do some work on. So if anybody listening to this or in the comments wants to get in touch with Andre, the his contact info is available there.
Yeah, hit me up.
Yeah, will be in the description and in the show notes. That's also, I don't know, on the Twitter side, I feel like the managing the OAuth security, like managing your OAuth endpoint, being able to blacklist apps which are misusing it, is something that we didn't really understand was important until relatively recently. There was, I think, a Google thing which went around in like 2017, actually when I was at Stripe. And we were very lucky because the lady who ran our internal phishing tests had also run an internal attack testing whether she could get people to approve a malicious OAuth app, which worked great. And so was what the way she ran. Her name's Carla. She's got a talk up on that she did a Black Hat a few years ago called Ichthyology. Phishing is a Science, which is brilliant, and I will link in the description and notes. But she always used the internal phishing tests, which we were required to do by one of our compliance regimes, not to go shame people for clicking links or whatever, but to drive internal change in the business. And so Carla got us to set up single sign-on. Carla got us to to set up a allow list for OAuth apps on our Google Workspace rather than doing a block list. Carla is, I forget what the third thing was, but Carla is also the reason that AWS supports YubiKeys now.
That's the key, because I feel like auth namespacing would not matter because they're just harvesting usernames, logins, but having multi-factor auth would have helped for sure.
Okay, they're interesting on the part of Twitter.
Yeah, just in the example that I was using, just being able to log on username with your username and password and just be able to DM everyone with a link, like no amount of auth would have helped.
Okay, yeah.
And
I guess, was it actually OAuth that they were using, or were they actually popping up a fake Twitter login form?
Yeah, they actually duplicated the actual login form, and they were just harvesting straight up, and then they were just logging in. Yeah.
So then they're two-factor, especially of the YubiKey kind, where not everybody recognizes this, but it's actually checking the URL that you are sending your credentials to for you, because it turns out that humans are really bad at bitwise string comparison, at catching that iTwitter.com rather than twitter.com, whereas computers are really good at bitwise string comparison. And so we should make our computers do bitwise string comparison for us, and YubiKeys do, or all the other little U2F tokens. And so, that is the kind of thing that would have helped there a lot. I think that attack is still possible with a phone-based 2FA.
I mean, at the end of the day, also Twitter should have been noticing that the same IP address is probably logging in 100,000 times to 100,000 different accounts.
Yes.
Yes. Also
this
stuff
is
like that.
Where's the rate limiting on Twitter's login form? Actually, maybe those drops you saw in the analytics were Twitter hastily implementing rate limiting and returning the rate limiting knobs on their login form.
They probably blocked an IP and they got a different IP and then they went back up and that kind of thing.
Yeah, exactly. Folks who I think when I talk with software developers, software engineers who are working on the sort of more feature side, I think folks just like have never been on the receiving end of this stuff, or if they have a login form on the internet, have maybe like looked to see what is being sent to their login form. And if you have a login form on the internet and you do not have rate limiting on it, and you have not looked at it recently, maybe go check your logs, see what people are sending.
Yeah, I mean, yeah, I was going to say, ideally, whatever S-crypt or like bcrypting you're using is kind of implicit rate limiting just by overloading your system. But
well,
yeah,
up to a point, and we really hope that you're using scrypt or bcrypt and not, I don't know, MD5. There's still a number of bad login forms out there on the internet.
That's true.
It's nice to have extra rate limiting, because even though like those are the password hashes which you should be using along with Assault, this gets into a whole. I am actually contemplating doing a video about some of this stuff, but this gets into the weeds. But like, if somebody is sending you more than like one login request a second, even one login request every 10 seconds, that is not a human typing their password. That is an automated system.
Yeah, I mean, maybe we're just a few years away from not wanting to discriminate between computers and humans, so we'll see.
Maybe. I'm still very skeptical. If ChatGPT is sending me more than one login request a second, that is also too many. Thank you.
Get a different IP address. Come on.
Get a different IP address, yeah. That is going to change things in interesting ways, and I'm very curious to see what happens on the account security side. I'm not super looking forward to it. I'm not thinking that it is going to change things for us in positive ways. It is going to introduce new and interesting adversarial patterns that we are going to have to deal with. So
for sure.
Yeah, I did a talk actually. So we met via our mutual friend Patrick McKenzie.
No, we met through Willie, I think.
Oh, okay.
Yeah, but I have met also Patrick McKenzie, but
cool.
We're not close.
Okay, cool. Never mind that. I did a talk at MicroConf, which is the conference that Patrick McKenzie goes to and talks about a lot.
My wife actually works there. She's Tracy Osborne. She's the director of Tennessee.
Oh, brilliant. Okay, cool. Oh, I hadn't realized that connection. Okay. It's a small world. I gave a talk at MicroConf this year about the 3 simple cybersecurity changes every Bootstrap software as a service business needs to make. And one of them was implementing rate limiting on your primary or on all of your authentication endpoints. So was well received. I had a number of people come up to me afterwards and be like, so the CEO is asking the CTO, like, are we doing that? And the CTO is like, let me double check. I'm like, okay, great. My work here is done.
Nice.
I think the answer was yes for most people, but still important to know that and to know why. Because until you have run something at scale, you've probably never had the experience of somebody, trying a bunch of password dumps at you, or in this case, cloning your site and setting up a phishing version of it and trying to trick your users into giving away their credentials. And
exactly.
Yeah.
You up for one more?
Yeah, absolutely.
All right. So the last one features George Hotz, which some people might remember from hacking the original PlayStation 3 and the iPhone.
Yes.
And a bunch of other stuff. Now he also started Comma AI, and now he started another AI company.
Okay. Most recently, I remember him from telling Elon he would solve all of Twitter's problems in a week, coming on and he tried, and 4 days in, noping out, and and having a long Twitter Spaces with Elon about how horrible things were inside, which to me sounded like someone who had never encountered a large software system before.
I think they had a mismatch of expectations, both of them.
Yes.
Yeah. So one thing most people might not know is he's also been on and off involved in some Ethereum stuff, which is just like a cryptocurrency thing that I also happen to work on and off. And so some backstory. One of the interesting attributes of Ethereum is this collectively owned computer, essentially, where we can all execute. We have these guarantees where all the code executed on it will be 100% right because every node verifies it.
For some values of right,
it'll match the spec. It'll always execute accurately.
It will. The computer will always do exactly what you told it to do. Yes, for better or for worse.
And it also has a lot of interesting censorship resistant properties, where basically in order to stop a transaction from happening, someone would have to burn billions of dollars at a time for an extended period of time for as long as they want to stop a transaction from happening.
This does also make security updates hard, unfortunately.
Yeah, it does. It's a huge orchestration that happens once every year or two, where it's like many hundreds of people involved all over the world. That's very magical to watch.
Okay. Yeah.
But yeah, so one of the kind of the constraints in order to maintain these decentralization properties and for everyone to be able to run a node at home on their laptop, there's a fairly small limit on how much throughput it can handle. People often make fun of it for having something like 10 transactions per second or something like that.
I believe Patrick McKenzie calls it a slow database.
Yeah.
Yes.
But turns out we can solve it by this innovation called rollups. And essentially, we can run the transaction somewhere else, and we basically commit to a batch of transactions on Ethereum, and we can prove that they executed accurately. So back when these rollups were first kind of designed / discovered, people were like the theory of it was fairly well established, but implementation was still kind of a long road ahead. This is 2019, maybe 2020. Actually, I have a date. 2022 is when this story happened. So the way the story goes, man, I'm retelling someone else's story, and then my story comes in later. The people working on these rollups, they're hanging out in like a San Francisco cafe, and they're just like bashing their heads, like, how are we going to build this? How are we going to build this? And then they turn, and George Hotz is there next to them, and they know him because he's kind of experimented in the ecosystem, and they know he's really smart, so they just like start like brainstorming with him, and he gets nerd sniped, and they basically convince him to build a proof of concept of a rollup in exchange for a very generous amount of money. But the term that they came up with is that they're gonna do an initial bug bounty and a like $50,000 bug bounty, but the money's going to come out of his compensation if there's bugs. Which is kind of an interesting arrangement. Basically, he has to build this. They're going to pay him, but if there's bugs in it, he's going to pay for the bugs.
You have an immutable piece of software where once you deploy it, it's going to be very hard to update it, and it is going to be responsible for millions of dollars. So, better get it right the first time.
Well, yeah, and the nice thing about these kinds of immutable softwares is you can still deploy more instances of it and just say, this version is the new version. You can disregard the old version. Right, so it's immutable, but also there's kind of a like social layer where we can still orchestrate things around.
Yes, for sure.
So
use the new version of the contract, not the old version of the contract.
Exactly. And this is before it actually may have made it onto main. In fact, they just launched some version of this onto mainnet, as we call it, last week. So
it
took this long to actually productize this.
Got it.
But this was kind of an initial very rough proof of concept. There's like a lot of bash.
Sure.
It was all kind of gum and duct tape. But anyway, so George goes and hacks away for days and maybe a couple of weeks, and then gives them this thing and like takes their money. And then they do this bug bounty, and I have this business partner that occasionally do bug bounties and security audits. His name is Max, and we saw it. I'm like, let's try to earn $50,000.
Yeah, absolutely. Take George Hotz money.
Yeah, exactly. And so we kind of allocate a few days to this. We sit down, we pull all the source of the instructions, we try running it, and there's an error. Just like right off the bat.
Okay.
And
it's like you can't get the thing you can't get the source code to build.
No, it builds and it runs, but then it gives you an error.
Oh, okay.
My co-auditor Max, he's like, I'm just gonna post this error on the Discord, like ask them what's going on, like, is this supposed to happen? And I'm like sitting there, I'm like, wait a minute. If this is airing out, this might actually be a bug that is a $50,000 bug, and he just posted it on the Discord.
Oh no!
And I'm like smacking him into getting him to delete the message as quickly as possible.
Yeah.
And yeah, so it turns out we're the only ones that tried to run it on live data. When they were developing it, they ran it on like a a like test net basically. So
Sure.
it's like a test environment.
Right. Right.
And no one really bothered to run it. And there's certain types of transactions that didn't work with the types of proofs that it had to generate.
Okay. Interesting. Okay.
So we basically spent a day or two debugging it and narrowing down the problem and like documenting it and doing like a proper security report, submitting it to Immunefi and all that. And yeah, long story short, we got $50,000.
$50,000 of Red Hat's money. Congratulations!
Yeah,
yes.
Yeah, I mean, to be fair, he's honestly, that experience has reaffirmed a lot of my respect for him. He's obviously extremely smart. He's really good at like building a mostly working system extremely fast. It's extremely complicated. And yeah, like just like a quick summary of how it works, just to kind of give you an impression. He built an implementation of the MIPS VM that runs on the blockchain, and you basically create.
So this is an older processor architecture.
Yeah.
So was that an IBM thing?
No, it's an old RISC. It's a RISC architecture that's extremely simple. I think it only has like 30 something instructions.
Okay, cool.
It's extremely reduced, as you would say.
Okay. Right. That's what RISC stands for, reduced instruction set computing. There was a big fight back in the 90s about whether Intel and the CISC architectures were going to win, or Sun and
RISC,
DEC and the RISC architectures were going to win, and eventually we combined them, is my understanding.
I mean, ish. I mean, RISC does seem to be kind of making a very strong comeback lately.
Well, yeah, pure play RISC. ARM now is pure play RISC, and it does seem like it is eating Intel's lunch with the way that Apple is deploying it and the way that ARM themselves are deploying it, and it gets used in a lot of mobile stuff. And yeah, it's just good in a lot of ways. So
to kind of give you like a little taste of how this system works. So he built a MIPS VM.
Sorry, the Ethereum blockchain already has its own VM.
It runs the EVM, the Ethereum VM.
So we have a VM and a VM, right?
Yeah, so he built a MIPS VM inside of Ethereum VM because one of the main Ethereum node implementations is in Go, which is able to build into MIPS. So basically, you could build the entire Ethereum node, build it into MIPS, and execute it on chain using the MIPS VM, using a binary search to have a challenge system to figure out where you disagree on an execution in any given transaction. So basically, you have a challenger and a defender, and they would both do this. And in order to avoid executing probably millions of instructions or like billions of instructions, you would do a binary search of instructions, which is log n. So instead of billions of instructions, you would end up running like 90. And then you would kind of go back and forth until you agree on which instruction you disagree on, and it would only execute this one instruction on chain.
Okay.
Which is like reasonably expensive, but it's just one instruction instead of like billions of instructions.
Okay.
It's a really clever design, and I have a lot of respect for it. And he built this whole thing in weeks that mostly worked except for a small nuance.
The small nuance being that how do you ensure that you're running against the same data on?
So you like pre-commit on chain. So you like post a hash basically on chain of your data, and then all the inputs is based off of that hash.
And so the issue here then was not that like the data was different between the different Ethereum executions. So backing up from my understanding for just a second. So we can think of this as a way kind of running Ethereum on Ethereum in the way that we would run like Windows in VMware on Windows for testing purposes if you wanted to have a virtual Windows box, for development or debugging or security auditing or whatever.
But you're not running all of Windows. You're only running one instruction that you disagree on.
Okay, yeah.
But in theory, you would be able to run everything.
You could run all of it, but you have this disagreement about this one instruction, which is probably the like commit of some block, maybe, or.
So another kind of important thing, the way these rollups work. So there's a few different kinds of rollups. There's zero knowledge rollups and there's optimistic rollups. Zero knowledge rollups use this a branch of really interesting cryptography called zero knowledge cryptography to essentially prove instructions. So you can run an arbitrary set of instructions and you can create a small proof that you can just verify, and you can have a mathematical guarantee to some amount of certainty that it was executed accurately.
It's a way of giving me a thing that I can hand to somebody else where they're of proving that I did the computation that I say that I did, is my understanding.
Yeah. So like imagine something, not now, but in like 15 years, Amazon Lambda, for example, that like runs arbitrary functions, would not only run a function, but also give you a kind of a like proof that you can verify that it ran it accurately. So that's kind of what you can do with zero knowledge stuff. But and then there's optimistic rollups, which work differently. They rely on in order to communicate state from the rollup to the Ethereum main network, they rely on a fault proof and a fault proof window. So basically it means because Ethereum itself can't run the whole rollup to verify that it's running accurately, it basically has this assumption that if there weren't any fault proofs within the last week, then the transaction is by default accurate, which is kind of an interesting trick.
And a fault proof is an adversarial sort of thing where somebody else is coming along trying to verify this, and if they find an error, they post a fault proof, which invalidates the transaction or can be used to.
Yeah, and the nature of that fault proof is exactly what we mentioned earlier. Is basically the state root, which is kind of your like hash pre-commitment on the state of the blockchain as you saw it in the beginning, and also which is kind of the like pre-commitment of the execution. And once you provide that proof, you go into that kind of binary search to figure out where the disagreement is, and then only that one instruction of disagreement gets executed on chain in order to resolve to decide whether the transaction is good or not. So basically, I can challenge any transaction that's kind of in the inbox of the optimistic rollup on chain, but I have to go through this kind of back and forth, and one side wins, one side doesn't. But really,
this presumably costs money.
Yeah. I mean, the amount to execute a single transaction. So
okay.
Maybe a few $dozen or maybe $100. But there's also a whole like bonding process. So in order to challenge, you have to put down a bond that's strictly more than how much it would cost to challenge it. And there's like a whole kind of economic security system because it's cryptocurrency and it deals with money.
So this bug that you found then, where you were getting an error as soon as you tried to start executing this on live data, was it just that it there were transaction types in the blockchain that it had to interact with that it wasn't expecting, or?
Yeah. Basically, it was it wasn't able to create a proof for certain types of transactions, and the reason the bug was important is because there's that 7 day window for someone to give a proof, and if you can break the prover, if you can basically make it not be able to execute any proofs after some transaction, that means you can put incorrect transactions and no one will be able to actually prove you wrong. So being able to inject a transaction that a prover won't be able to, it'll get stuck on is actually really bad.
Interesting. Okay. Fascinating. And this was just sort of like, again, that there was a type of transaction that the prover wasn't expecting and didn't have a branch in its sort of case statement for it to handle it, and so it was just throwing up its hands, being like, I don't know what to do with that, and that broke the whole system.
So something like that. It was something to do with the memory oracle. Okay. So this is a whole other thing. We can get into the weeds if you like.
Goodness. Yes.
So
we got time.
Okay. So because you're running a VM inside of a VM,
right?
The VM at the very bottom doesn't have access to all the memory you would otherwise need.
Okay. Sure.
So like it can't just like be like, oh, give me memory address this and that, and kind of load state and stuff.
In fact, you really don't want your VM to have access to all of the memory. That's one of the reasons you run things in VMs is so that they only have access to the memory that you give them inside the VM, and they can't touch the memory outside the VM.
Well, the interesting thing is they don't have this particular VM has no access to any memory. It only
Okay.
has access to proofs of memory. So it
Okay.
has a pre-image oracle, which
Okay.
basically means the way like proofs work generally is just like it's just these like Merkle trees of hashes. So it's just like hashes of hashes of hashes of hashes, and you have some kind of signature over them, and then you can prove that it exists somewhere in this tree. So they have this. Might be mangling this. It's been a few years, but in order for the VM and the inside to work, it needed to anytime you need to access data, it needed to query the hash of the data rather than the data itself. And then there was like this pre-image oracle that would take the hash and map it, do the operation, the actual data, and then kind of just give it the result, essentially. And those basically the way that the pre-image oracle worked to generate these hashes. It wasn't working for all kinds of transactions. It like turned out they needed to do a fairly substantial re-architecting to make it more generally, but yeah.
Oh, interesting. Okay. And it sounds like they had not run this on live data before they, published this. Did they actually like ship this to production?
No. This is like pre-production. This is
Okay.
just like George Hotz being an amazing cowboy, whipping this out in a couple of weeks, writing probably like 6 months worth of work in a couple of weeks, and then dumping it and then leaving.
Right. Okay.
And they're like, okay, let's see if this works.
Right. Okay. And it turned out that they had another 6 months worth of work to do.
Well, they had another couple of years worth of work, but yeah, as you said, there's like billions of dollars that is on the line. So
okay,
it has to be extremely careful.
I guess. I mean, I guess they got the proof of concept that they wanted.
Yeah, exactly. Because the whole thing is they wanted to figure out an approach that they could work towards actually formalizing, and I think George helped them kind of throw them in the right direction, essentially.
Sure. Yeah. Okay. Yeah. At least here's the thing we know works on this subset of the problem. Now, how do we generalize it to the full problem? Even if that is, I guess, several more years worth of work, they still like getting from 0 to 1 was pretty important.
Yeah, I think using MIPS was strictly his idea because I think he has a lot of experience with RISC processors back from his like PlayStation 3 days and all that.
Yeah, I very much think of him as like a more of an embedded person than a application person. Okay, that is like just from a like technical from a technical standpoint, from a like wild-eyed kind of like hacking like standpoint.
Yeah.
Like the idea that you can run Ethereum an Ethereum VM on the Ethereum blockchain by the way writing a MIPS VM in Ethereum, and then to run that is kind of wild. It's computers all the way down.
Well, it's not just that, but basically the implications of this is anything that you can build into MIPS, you can run on Ethereum now, or at least not run per se, but you can actually prove on Ethereum. And then there's a bunch of other rollups that do other stuff that you can prove basically anything, like using WASM or like whatever. So kind of from like an abstract node sniping type of perspective is like being able to like write a program and relatively cheaply have 100% guarantee that's worth many billions of dollars that it was executed accurately is something that like any random person can do now is really wild.
Right. Yeah. And like there are whole Linux distributions which are for MIPS. Like that was one of Debian's, or there were. I don't know if Debian still builds to MIPS, but it used to. So you could have conceivably anything that you can run in Debian now, I guess, proved on the Ethereum blockchain, and wild.
It's a neat environment, and like I think kind of at the end of the day we will see some like traditional kind of the AWS's Lambdas and stuff offering similar guarantees eventually, but I think there's just not enough market demand for it yet.
I feel like you talk about the social controls which help manage that, and I feel like that's where we get a lot of that kind of stuff from AWS Lambda. It would only be in really niche, narrow, sort of like extremely high value use cases around things like cryptography, around things like money, where we would want these kinds of guarantees.
Well, I think also just for like offloading operations, like I think a lot of people are uncomfortable. For example, like running AI. People like, would you trust all your AI to be run non-locally? Like, what if they're influencing your results?
I mean, clearly people do. Clearly people do.
They do, but it's also a really big argument around it. Whether people feel okay with it, whether they trust the results. Like,
I mean, I don't trust the results, but I don't trust the results for reasons outside of like whether the computations got performed correctly. I don't trust the results because there's something higher in the stack, which is does not care about the truth value of its output.
But once we solve that one, then we're going to work our way down the stack, and then we're going to have other kinds of issues. So
maybe, we'll see. Also, like given the amount of compute, I guess the compute is going to training as well as to deployment, but the amount of compute that it takes certainly to train these things is like data centers.
Yeah, well, I mean, like just as an example, is like if you wanted to, okay, so like one, I'm trying to think of a good kind of mainstream example. Like maybe in some games that we currently rely on client side DRM to like guarantee that you're not like modifying the game in some way. Instead, we could have instruction proofs, maybe.
Right. Yeah. Right now, that seems to be done mostly from a client verification standpoint rather than, verifying with the actual computations that the client is performing. Although,
well, that, and it's also everything's being replicated server side as well. Which, if you have instruction proofs, then you don't need to do that.
Interesting. Okay, we're now getting like deep into the weeds, and you also get a preview of some of the stuff that, if you do not live in the Valley, are kind of conversations that I have around the Valley a fair bit with people. And so there's like open areas of research and things to build and ideas to explore. But very cool stuff. Any other stories to share with us today, Andre?
That's all I got for now.
Okay.
But I'll try to manifest some more in the future.
Okay, yeah. Well, it would be lovely to have you back on. And this has been real lovely. Where can people find you online?
I'm Shazo everywhere. It's Shadow, but with a Z.
Great. Okay. Cool. Twitter, Blue Sky, Mastodon.
All the usual. Like Farcaster, if you've heard of it, and Shazo.net on Google, on Bing, and so on. And so forth.
Okay. Cool. Yeah.
On Keybase.
Great. Love it. Gotta be on Keybase if you're doing crypto.
Gotta be on Keybase.
Yes. Awesome. This has been the War Stories podcast on Critical Point. I'm Kevin Riegel. This is Andrei Petrov. And Andrei, what is it that you're doing now? Like,
I mostly do a lot of random open source stuff. I build a lot of Ethereum infrastructure stuff. I work on some Ethereum libraries.
Cool. Yeah. Cool. Okay. So you moved on from Python infrastructure to Ethereum infrastructure.
Yeah, I mean, I've been working it for almost a decade now, on and off. But yeah.
Okay. Cool. Yeah. Cool. Very cool. Yes, this has been the War Stories podcast on Critical Point. Kevin Riegel, Andrei Petrov. Thank you so much, Andrei. It's been a ton of fun.
Thank you.
We will see you all next time.
Take care.